You know, every complex system has its ghosts. Those weird intermittent problems that pop up out of nowhere, and then poof, they're gone. In this explainer, we're going on a ghost hunt. We're chasing the phantom latency. And it always starts the same way, doesn't it? With a report from the field. A single, frustrated user. It's a message we've all seen. And right there, that's our crime scene. The user experience is hurting, but the evidence, it just disappears. And that's the real kicker, isn't it? I mean, if a service is completely down, that's obvious. But a service that's just slow for a second for some people, some of the time, it's like it leaves no fingerprints. It's the perfect digital crime. So where in the world do you even start looking? Our investigation kicks off not with a huge explosion, but with a whisper. Just a single, really frustrating alert telling us something's wrong. So, the pager goes off. A P99 latency alert has been breached. Now, that just means the slowest 1% of requests for a really important API are taking way too long. But of course, by the time we go look, everything seems fine. Our system's this mix of serverless stuff on Cloud Run and containers on GKE, all chattering away. The phantom is hiding somewhere in all that complexity. All right, the investigation is officially open. And what's the first step? Well, it's always the same. Line up the usual suspects. And this brings us to that classic question. Is it our code or is it the database? On one hand, you've got our application code. We wrote it, we deployed it, we should have total visibility. On the other hand, there's our managed database. It's an external dependency, and sometimes, let's be honest, it feels like a total black box. Is the problem a bad query we're sending it? Or is the service itself just having a bad day? To figure that out, we need our number one forensic tool, the distributed trace. Using things like OpenTelemetry and Cloud Trace, we can follow a single request on its entire journey through every single service. This trace, this is our case file.
So with our tools ready, it's time to set a trap for our phantom and follow that digital trail.
And we finally get it. We capture a trace from a request that actually triggered the alert. We open it up and, at first glance, everything looks fine. It's just a sea of green, happy, healthy-looking spans. Every microservice call is finishing in just a few milliseconds. But then, we see it. Hiding in that sea of green is one long, angry red bar. A single operation that ate up almost the entire request time. We've got it. Our first real clue, the smoking gun. So here's where we found it. The request comes into Cloud Run, gets checked by an auth service, then processed by a worker on GKE. And that long red bar? It lines up perfectly with the very last step, the call out to our managed database. We've pinpointed the scene of the crime. So, case closed, right? Not even close. We know where it's slow, but we have no idea why. Is it one specific query? Is it only happening for certain customers? Is the database just overloaded? The trace gave us the location, but it didn't give us the motive. We need the full story. This is the moment we go from being system monitors to being real detectives. We have to upgrade our forensic tools to get way more context. So, we dove back into our application code and beefed up our OpenTelemetry instrumentation. We made two pretty simple, but as it turns out, incredibly powerful changes. First, for the database span, we added the actual SQL query text as a custom attribute. Second, and this was the real game changer, we added business context, things like the customer ID and their subscription tier. The power of this is just, it's immense. We're not just looking at abstract technical data anymore. Now we can connect a performance problem directly to a piece of our application's logic, the query, and to a piece of our business logic, the type of user. We deploy the update and we wait. Pretty soon, the alert fires again. We pull up the new souped-up trace, and there it is, clear as day. That long red span now has labels attached to it. We can see the exact inefficient query being run, and right next to it, the user tier label says free tier. The phantom wasn't random at all. It was an unoptimized feature being hit hard by a specific group of our users. So we solve the mystery, we optimize the query. That's great. But the real win here is learning how to solve the next mystery even faster. And that brings us to the key best practices for any investigation. So here are the key takeaways for your own detective handbook. First, instrument everything by default. Don't wait for a fire to install smoke detectors. Second, always add business context to your spans. User IDs, tenant IDs, feature flags. This stuff is investigative gold. Third, trace your external dependencies just as carefully as you trace your own code. And finally, the most important rule of all, make your traces actionable. They need to have enough information to not just find the problem, but to actually solve it. So here's the bottom line. Without context, a distributed trace is just a pretty waterfall graph. It's just data. But when you add context, the SQL query, the user tier, the customer ID, that data turns into a story, a solvable story. Every slow request, every error in your system is trying to tell you something. Your traces are telling that story. The only question is, are you giving them the context they need so you can actually listen?